In this course, we will study modern physics, which is the study of things moving very fast, close to speed of light, or things that are very small, things at the atomic scale, molecular scale, or even the nuclear scale, so tiny particles. Modern physics was developed after the 19th century. So the physics that developed after the 19th century is known as modern physics, whereas the physics that came about before that is known as classical physics. And because Newton made a lot of contributions, as you will recall from first semester, to classical physics, classical physics is also sometimes known as Newtonian physics. So that's the physics leading up to the 19th century. Specifically in this chapter, we will study special relativity. So relativity is commonly associated with modern physics, but it was a topic which was studied way before that in classical physics as well, especially Galileo and Newton made a lot of contributions to classical relativity. In early 20th century, Albert Einstein came up with different versions of relativity, and that's known as modern relativity. Now, relativity is the study of the differences in the measurement of the same events made by different observers. So you have the same event occurring, but two different observers are looking at it, and the differences in what they see is basically what the realm of relativity is. Let's take an example of this phenomenon. So consider a train that's moving on its track, and in this train, a person throws a ball in the upward direction. So for a person who is in the train, a co-passenger, what the co-passenger sees is a ball that's going up and then falling down. So basically the motion seen by the co-passenger is this, the ball going up and then falling down. Now consider a person who's standing outside the train on the ground, looking at the same event, namely the throwing up of the ball, or throwing straight up of the ball. So for this person, there are now two different motions that are superimposed on each other. First, you have the up and down motion of the ball, and then secondly, you also have the motion of the train. Let's say it's moving to the right. So what this observer is going to see that a combination of up and down and horizontal motion. In other words, the person basically sees a parabola, which represents both up and down motion and the rightward motion. So this is just a small example of how different observers can be looking at the same event and seeing different things. And that's what relativity tries to study.